Many thanks to Sabu for yet another opportunity. Today's discussions pertain to the National Electricity Plan for 2035 and even beyond. You are aware we have discussed our entire country has one grid which is supplying synchronized 50 cycle supply all over India, except the islands, Andaman Nicobar and Lakshadweep, they don't get supply from mainland. Our power sector, which today largely depends on fossil fuel like coal, natural gas, causes over 40% of our carbon emission. Our carbon emission is around 3.2 billion tons. The government has committed it'll bring it down. So the power sector needs to reduce its emission. That's a general requirement. Reduce your emission, carbon emission. You can't continue with the old practice. So we have two demands on the power sector from the government side or the national level. One, reduce your emission. Second, give more power. You must have seen in the budget, which was presented on Sunday, that the government is opening up more, especially for semiconductor mission 2.0, for many other industries. They're going to start rare earths in many states like Kerala, Tamil Nadu, Orissa. So you require more industries to come up. You require more power, but less carbon emission. So these two are a little conflicting at this point of time. And we want to look at 2035, 10 years from now, and see what will be the situation. And there also we look at 2047. So I have a presentation to make, and I will just upload to you to discuss this issue and come to some conclusions which are really eye-opening for the planners of this country, as well as many engineers who are operating in power sector. I'm aware a lot of my colleagues from College of Engineering Trivandrum are here, who have huge experience in electricity board and other electrical engineering subjects. So I will try and put across in a very simple manner for all the people to understand. So I request my colleagues, erstwhile colleagues, to bear with me if I'm speaking a little bit of fundamental issue. Okay, let me upload my presentation. So when I said King Coal will rule, this is my question. King Coal will he continue to rule till 2035 or even 2047 is the question, and we will have an answer by the time we finish our discussion. I'm calling King Coal as King Coal because he has been ruling power sector for last 60, 70 years. Let's go. But before I get into our power generation issue, some basic electricity issues I'm going to discuss. One slide for the benefit of people who are not so much knowledgeable on technical issue. Okay. So some basics. As I told you, our entire country is connected by one grid. That I've already told you. Second, the unit of power is watt. But there are higher denominations. when you talk of somebody's house, it will be in kilowatt. If you're talking of some institution, say for hospital, then it could be in megawatt. If you're looking at some part of the grid, it will be in gigawatt. And if you're looking at the whole country, it would be in terawatt. So these are higher denominations of watt, because this will come off and on in the presentation. So gigawatt and terawatt, etc., are some huge quantities of watts. They are higher denominations. Domestic electrical appliances which you buy, refrigerator, AC, are normally indicated in kilowatt, how much power they need. So let's say you have an AC of 1 kilowatt rating in your house, in one of your rooms. That AC wants 1 kilowatt of power. 1 kilowatt means 1000 watts of power. It wants. If you run this AC for 1 hour, it consumes energy of 1 kilowatt hour. And that is your standard unit in the KSEB bill. When you see KSEB bill, it will be saying so many units you consumed. Actually, the unit is kilowatt hour. If you run your AC for 1 hour, which is a 1 kilowatt rating, then it will take 1 kilowatt hour energy. So see the difference between power and energy. AC needs 1 kilowatt power, but when you run it for 1 hour, it is 1 kilowatt hour energy. So energy is power into time. Just remember this, because you will find some graphs and all being shown, which is sometimes an energy. And we'll talk about why we have a different source of energy, etc. Right? Now, the same thing, I said kilowatt hour. It can extend to gigawatt hour. It can go to terawatt hour. Whatever is the wattage multiplied by hour is energy. Just remember that. Okay, I finished with the basics engineering. You have to just remember energy is power into time. In your house, the meter is fitted. It's called the energy meter, because it measures how much energy you consume, and your bill will be accordingly prepared. For 1 kilowatt hour of consumption, so many rupees will be the charge. So energy is what is your consumption. Power is the rating of the appliance or of the building or of the institution, etc., etc. Okay, so let us start our introduction to the topic. India has got 16% population of the world, and everyone, as per government, has got access to electric supply. As of now, every house in India has got supply by the grid, which I told you is one common grid. But India consumes only 6% of world supply. That means our consumption of energy is very low. But we have population is 16%, consumption of power 6%. We are very fortunate. We don't require so much of cooling in summer. Summer is not very long. Then you have a good monsoon. Then you have our cold places don't require so much of heating up. So your consumption of power is, energy is less. The Ministry of Power in Delhi controls generation, transmission, distribution, etc. They control it. They give the guidelines. They make sure the contracts are in place, etc. And they also import and export power from other countries. That's an important information. We buy power from Bhutan. We buy power from Nepal, but we give also power to Nepal in some other point. So at the moment, it's only Bhutan and Nepal which is involved with our power. Bangladesh is not there. But we have some plans to give to Sri Lanka and in the Middle East also, but that is not yet started. Our energy security and the strategy for that security is supply should be reliable, it should be affordable and sustainable. And all these things can happen. especially reliability and sustainability, can happen only if your grid is very stable. Just remember these 2 points. Your grid has to be very, very stable to make sure everybody gets supply reliably and in a sustained manner. India per capita consumption per day was 2.6 kilowatt hour. That's energy. A person used to consume 2.6 units. That is in 2014. Now it's gone to 3.8. There has been a growth in our consumption. Naturally, people are having more appliances at home. They are having washing machine. They are having TV. They have refrigerator. The consumption has gone up. And that's a good thing. Then the economy is improving everybody's quality of living. We are at the same time transiting towards renewable energy from erstwhile popular fossil energy. So we are looking at this. I told you there are two aims for us. We want more power for increasing demand, but less emission. And that is where the renewable energy has come in as a solution. So we look at that. How is the solution working? Is solution is there with solar, or is it solar plus wind? Is it good enough? Not, we'll see. So government is looking how to get all the power you want from a mix of sources. When I say mix, some can be coal, some can be natural gas, some can be solar, some can be wind, some can be nuclear, like that. So they make a mix of it, saying so much percentage, this, and then put together everything. That will be your total capacity to generate power. That's what the government works on it. So the National Electricity Plan for 2035, the document has been issued about 2 months back. And that plan says we should have so much of renewable energy, so much of nuclear energy, so much of some other energy, and so much of coal energy. It gives a plan. We are going to look at what are they saying in this plan, and are there any problems? That is what I'm going to share with you. So let us look at what are the sources in India. First is fossil fuel, coal, lignite, natural gas. That is one type of source of power. Second is nuclear, based on only uranium. We had hopes that our thorium plants will work, but it has not been proved so far for commercial application. So our nuclear power plants continue to work only on uranium, which we don't have enough. We'll come back to this point. Just remember, our nuclear power plants work only on uranium. Thorium is still an experiment which is going on. Then renewable, solar, wind, hydro is also renewable. You know, when the rain comes, it renews the water. So it's called solar renewable, biomass. All these are a form of renewable energy. And hydroelectricity and biomass, etc., can give for 24 hours. But solar and wind are normally around 12 hours in a day. So there is a little bit of variability in their availability. They're not available for 24 hours. So this is something which you have to factor in as we discuss. So all these combinations of 1, 2, and 3 is called the energy mix. And that's what the government works on and say, we will produce the necessary power for 2035 by working on a mix. And that is what is given in the plan. As far as India is concerned, there are other types of energy which the world, many countries are generating. Geothermal, tidal, wave. In India, it is not there. All are in research and development. Some have attempted and failed. So as far as we are concerned, point number 5 is 0 in India. And is not likely to come for next 20 years. So we can forget about point number 5. It is 1, 2, and 3. Based on their capacity, we have to make a mix. Okay. So how do you make a mix? From the generation side, you should look at fuel. Is it available? I told you uranium fuel is not available in plenty. So we have a limitation there. Then how much does it cost to generate power? And for information, solar is the lowest at 2.5 rupees per unit. Coal is 5. Nuclear is 6.5. Gas and pumped storage, I will come to this word pump storage, at 9. So it's very expensive. So you have solar the cheapest and therefore very attractive. And coal is at around midpoint. Nuclear is more than coal. And told you there's variation in generation during day and night, especially for solar and wind also. Sometimes wind is there, sometimes wind is not there. And another factor which you have to consider is how much time does it take to start a plant? Coal-powered plant take 5-6 hours. Nuclear takes about 3-4 hours. Gas-powered, this thing takes about 4 hours. So only after that, you can get the energy you want. It takes time to start the plant. It's not you press a button and straight away it starts. So there is an important factor to be considered. Even hydro takes about 3-4 hours because you have to release water, and before you release water, you have to announce to people on either bank that water is going to be released, and then only the power starts. You may not shut it down, but to start it, it takes about 3-4 hours. And similarly, from the load side, what is the peak load which is coming? Normally in summer, you find the peak load is during summer. Sometimes in some states, you find peak load comes even in winter because of heating requirement in the various houses and institutions and hospitals, etc. In winter, the load is something else. Summer, the load is something else. All this have to be considered. And during monsoon, also is a variation load. So when you formulate the mix, you take into account all these aspects, how the mix has to be, and how the grid is laid out, and then you work out. So this is what the National Electricity Plan is given. So I'm not going to go through this, but I'm going to give the final conclusion which the National Plan is given. But before that, how does the government go about these efforts? Government goes about on 3 aspects. Minimize carbon emission, I told you earlier. Second, reduce imports. We don't want imports of coal. We don't want import of gas. And just for information, crude oil, which uses petrol and diesel, is not used in power generation that much. Unless it is in some house, you have a generator running on diesel, or in some hospital, some generators running. So those are small issues. So main power, petrol and diesel are not used. But diesel is used in Andaman Nicobar Island and in Lakshadweep. So we're not talking about the islands. So coal and gas, we don't want to import. You want to reduce the import, you want to reduce the carbon emission, and you want to save on energy. Don't have to have inefficient appliances with us. So, minimize carbon is reduce fossil fuel and also increase grid stability. Don't use imported coal, use Indian coal only. Indian coal is not all that clean. It's got a lot of ash content. So but you want to pursue Atmanirbharta on that. And conserve energy by continuing with energy schemes. So I will show you what has been done in the last 15, 20 years on this front. Is that when you want to save energy, use LEDs. LEDs were not there before 2015 in a very popular manner. So far, the government has distributed 36 crores bulbs. Bureau of Energy Efficiency started certifying appliances so that it will tell you a 5-star, 4-star, 3-star ACs, refrigerators, depending upon how much of power they consume. Solar-powered emergency lights have started from 2010. Surya Ghar scheme. I'm sure some of you may be having a Surya Ghar scheme by which government subsidizes your solar plant to be kept on your roof so that you can take power from the sun directly. For agriculture, solar powered pumps have been started from 2019 as a part of subsidy for farmers. Industry 4.0 applications have come by which use power content. Solar farms have content in a big way, but solar farms have got a problem of called duck curve. I'll come to this in a subsequent slide and tell you a little more about it, which is very critical for stability. And government has started running green grids. That means all the green energy that has been coming from solar, wind, etc., go through a separate line, separate overhead transmission line. And this is almost run about 10,000 kilometers now since 2021. And on that line, power will be available only when solar is available. So it will be, let's say, 6 to 6 availability will be there on that as it stands now. And the government is also trying to reduce our transmission and distribution loss. This will get repeated T&D loss. They want to reduce it by smart grid, high efficiency transformers, etc. And also smart meters. I don't know how many of you received smart meters so far, but smart meters have started all over India. And it has significantly reduced theft and pilferage. And it is slowly expanding in all states. So this is the energy saving scheme. Now I come to duck curve. It's an important aspect. It's like a shape of a duck. That's why it's called a duck curve. The power available from solar is maximum at 12 o'clock in the afternoon or 1 o'clock in the afternoon. So if you've got a connection of solar in your house, you will be taking power from solar panel when sun is shining. When sun is shining, you will get power. You can use it in the house or you can charge your batteries. And in the night, when sun is set, that is somewhere here in the duck curve on the top, there's no more power from solar. Now you will use your batteries. And if you think that is also not enough, then you will draw from the grid. So as far as grid is concerned, you will find a large number of users. They go off the grid during daytime and come back to the grid with some requirement in the evening. So the grid gets loaded differently in the evening and during daytime by residential consumers. There are institutions also having solar panel. They also follow the same thing. For example, the airport in Kochi. The Kochi airport uses the solar panel for meeting all its requirements in the Nedimbasheri airport during daytime. In the evening, they depend on KSEB. So they load the KSEB at that time. So this brings some extra load on the KSEB. Like that, if everybody does like this, then your grid has to be capable of meeting everybody's requirement during night, not necessarily during the day. So the grid will go through some fluctuations in loading, and that can trigger some instability in the grid. You may have read 3 months back or 4 months back, Portugal and Spain did not have power for 2 days. And one of the main reasons have been the overloading which happened because renewable energy had gone off and the rest of the source could not take the load. So duck curve is something which is the phenomenon of solar power. Wind is also same, but wind doesn't follow exactly the solar curve, slightly different. But basically, the effect is solar and wind have got variability. It varies during the day. And that affects the demand on other sources. When the sun has gone set, then you find the equations are changing in the mix. This is something to be understood. Depends where is the grid supplying, what are the loads coming, what is the maximum demand coming, etc. All these are given in the plan, but this has been considered as an important issue. And we will talk about this consequence only in subsequent slides. So I've told about Surya Ghar, and there are so when you use Surya Ghar solar panel of small capacity, I think it's only 3 kilowatt hour or something, which the panel said, that uses lead acid battery, which is normally used in trucks, motorbikes, cars, etc. But when you want to have big solar arrays like in Nedumasheri, then you go for lithium-based batteries, which have got huge capacity. And of course, lithium-based batteries are not easily available in India. They're just about starting production now. So you find there is a problem with battery availability if you're talking of big power. So leave out the issue. Duck curve brings some problems to the grid. Just remember that. And your house may not be causing that problem to that much, but if all the houses do the same way, then there could be a problem to the grid. Okay. So what happened? The government, they said, let us tell somebody to study this in little more in detail. So they tasked Niti Aayog, saying, tell us what should be the mix in 2047. So 2035 and 2047. Please study up to 2047 and tell what should be our mix of power. Where all will the power come from for the whole country? Study it and give us some report. So Niti Aayog was tasked this in, I think, 2023, and they have submitted the report. I'll borrow some inputs from that report. So government told Niti Aayog to prepare this report, and they studied the report. But I would like to tell you, at this point of time in 2026 or 25, coal is giving 72% of energy as of now. And renewable energy is only 28%. When I say renewable energy, I'm including solar, I'm including wind, I'm including hydro, and I'm also including nuclear. All this put together is only 28%. Coal is giving 72%. But if you compare their capacity, it is almost half-half. So government says, we have set up 50% capacity in renewable. It is only capacity, but it cannot deliver because of various issues. So come back to this. 50% capacity coal, 50% capacity renewable, but power given or energy given is 72% from coal and 28% from renewable. So there is this imbalance which is already there as of today. And how to correct it is the issue, because you cannot go on like this, because then you will be burning coal till we are able to find another substitute. What is the substitute the government is thinking of? Government has got some plan that we should substitute and reduce coal, because carbon emission is dependent on how much coal you burn. So we look at that, how we go around. So as I told you, variability is an important issue regarding stability. So Niti Aayog has found out for 2035 and 2047 how it will grow, how much power is required, because how much energy is required in 2035 or 2047. It's all based on some estimates. So how did Niti Aayog do this estimation? Let's take 2025. What is the present situation? In present situation, our capacity is 505, out of which coal is 249, almost half. The rest, everything is half. There is solar, there is hydro, there is wind, there's nuclear, and it's a little bit of bio. And so you find it's 50-50 almost. But when it comes to consumption, 72 is from coal. I told you that. Even though capacity is only 50, they give 72. And therefore, carbon emission is depending on 72%, while 28% of renewable is supporting a little bit of reduction in carbon. So you find that we need to increase this green color and reduce this brown color, and thereby you will achieve lower carbon emission. There are some details, but there's only one thing which I want to flag. I was surprised when I studied this. Our transmission and distribution loss today is 17%. That means if Kudamkulam nuclear power plant gives 1 gigawatt or 1000 megawatts it gives, by the time the power is received somewhere else and started using and consuming energy, 17% is lost in transmission distribution. It's a huge issue. We're losing so much of energy in transmission and distribution. We should find technological solutions are required. Some are being suggested in the report, but I think this is an issue which is not going to reduce considerably, but there could be some reduction. I'll touch upon this as we go along. So let us look at what have been the three sources of electrical energy in 2025. In 2025, I'm saying. First is coal. I told you emission is high. It can be reduced if your nuclear and hydro and biomass can expand, because they have got no variability. They are available round the clock. But this black cloud will be there of carbon emission for coal. Then there is another type called nuclear, hydro, and bio. No carbon emission. Reliable, no variability. It doesn't vary during the day. It's very important. If you can bring this yellow color up, then brown can go down, because it has got all the good properties of fossil fuel. On top of it, it doesn't have emission. The last one is solar and wind. No carbon emission, but variability is limiting the utilization. So you require storage, which is for either by battery or pumped hydro. I will talk about pumped hydro. And this is very, very critical for grid stability, because it being available only for 12 hours a day maximum. So let's go further. Who consumes this power? Industry is 42%, domestic so-and-so, agriculture so-and-so, railway so-and-so, etc. The report says in the years to come, there are three sectors which are going to consume huge amount of energy. Electric vehicles, data centers, and railways. These triple combination is going to really demand a lot of energy. And if you look at what is happening in our budget, which is presented 2 days back, data centers have been given a big push. EVs are already under big push to reduce pollution of diesel and petrol. And railways also starting hydrogen train. I think in another 2-3 months, the first train will run on hydrogen. And therefore, they're also consuming a lot of power. So these three will consume a lot of power in the years ahead. And that has been factored in by Niti Aayog in their report. So let us look at what will be the scenario in 2047. Niti Aayog says, I have calculated how much energy is consumed by industries and transports and commercial building, residential building, telecommunication, cooking fuel. There's that various sectors have calculated how much they are doing in 2022. Then I've estimated they'll grow like this. And from the growth, I will say in 2047, I require so much of energy. So they have calculated a graph. It's a fascinating graph. Niti Aayog says in 2047, 85% will be green. and only 15% will be coal. Green means what? Solar, wind, nuclear, hydro, all these are part of green. And what is a part of non-green or black is coal and natural gas, fossil fuel. They said 85-15 is going to happen. How it will happen, what all the correction mechanisms are required. Now you remember the mix. The mix, the renewables plus renewables plus nuclear plus hydro should give 85%. And coal will give only 15%. That is what Niti Aayog has worked out. How it will happen, we'll discuss. Or will it happen at all? So India's power capacity is 505, as I told you earlier. We generated a lot of energy, meeting our requirement. 17% was lost. In 2047, this is the 85% green and 15% this. From this, you require a huge expansion for renewable, for nuclear, for hydro. All this need to be expanded. And a lot of storage mechanism had to be built so that the disadvantages of solar and wind are reduced, and that can form the 85%. This is what Niti Aayog is saying. So let us look at what will be the first step. Let us take 2035. In 2035, as per National Electricity Plan, 249 coal gigawatts will become 307. That means they'll produce a bigger black cloud of emission. There's no doubt about it. This is what the capacity is being sold. And we presume the utilization also will be more. Renewable is also going up. Renewable but not variable. Nuclear, hydro, etc. will also grow from 76 to 154. They're going in the correct direction. Green also going in the correct direction. Total will, what was 505 will become 1,000 something. We'll double our capacity. But emission is not reduced. Emission is not reducing enough. And I'll tell you why emission is not reducing. This 154, which has come from nuclear, from bio and storage, is not big enough to reduce coal. 2035, we want more power. If I go back, you see this graph. I require this much of power. Today I am here. I require this much more power. Who will give that power? Who will give that? Energy. Who will give that energy? Whatever hydro, nuclear, etc. are doing, that is not good enough. It has to be only coal. And till 2035, coal will continue to drive the power generation, and therefore energy will be consumed from coal. More carbon emission. Okay. Now, the report also says India will require 1 terawatt power by 2035. I told you sometime back, it is 1,000 gigawatts. 1,000 gigawatts is 1 terawatt. So 1 terawatt. So this capacity should be there. So they broke down, I'm talking about the National Electricity Plan. Whatever I told you, the previous graph, 307 coal, something else. And nuclear is still very low in this report. Why? Today, nuclear power in India is producing only 9 gigawatts. 9. Today, total capacity is 505. Nuclear is 9. Only 9. Suppose nuclear power plants are coming in 2-3 places. If they all get completed by 2035, then nuclear will be 25. nuclear is going to be 25 gigawatts in a total of 1,000 in 2035. So our nuclear power plants are not growing adequately to relieve the coal, because you require some source of power which has got no variability. And the no variability can come only from nuclear, hydro, or storage. So this is an issue. And one of the important points is that we should have more nuclear. If you recall, last budget, government said we will produce 100 gigawatts of nuclear power in India. I'm saying in 2035, it will be only 25. When will the balance 75 come before 2047 is something which we'll have to face the challenge, how we are going to do it. So nuclear is not going to help us much, is my conclusion, and I will substantiate with some details in the subsequent slide. So in 2047, as per Niti Aayog, he'll say we'll manage all this. Nuclear will be 100, hydro and pump storage will be 115, coal can come down, total can be 2 terawatt, etc. And this will be the distribution of energy. But the whole thing depends on how hydro pump storage and nuclear can be developed in the country. So I come to a conclusion that coal can be dispensed with. Some portion of coal can be dispensed with only if nuclear is built up and storage is built up. Energy has to be stored. Electrical energy has to be stored. How it is going to be stored? Battery is one way. How many batteries, huge capacities can you build? So I will talk more about storage. So we will reduce the whole discussion. How can nuclear and storage build up and reduce coal to reduce carbon emission? So our whole thing has come down to this one particular sentence: how to build up nuclear, how to build up storage. So this is the most crucial for our reduced carbon emission and increased stability. Okay. So I'm going to talk to you about what is pumped hydro storage. Very interesting concept. There's a reservoir here. Let's take it as Idiki. So Idiki releases water. When it releases water, the generators there produce electricity. And you get power and you can draw energy from it. The water goes down and finally it'll go to some river and go to sea. What pumped storage is, it takes water from here and pump it back to Idiki. You understand? That means this water which has already been used for generation of electricity in the turbine is flowing down. From there, you draw water and pump it back to Idiki. This pump will work on electricity. For that, you use solar. So during daytime, when solar is available, you pump water from the channel and take it back to Idiki. I'm giving Idiki as an example. It can be any hydro energy plant, and pump it back. And then you will continue to get electricity by releasing the water. Again, you pump it back. And these can happen simultaneously. When you're releasing water, water can be pumped on top. So scientists have estimated that the efficiency is around 70%, because you're getting free electricity from sun to pump the water up. And you will release the water and generate new electricity. So this is called pumped hydropower storage. China is doing in a very big manner to overcome the problems of storage. They are able to store electricity, like they are able to convert hydro plants to run for longer days and months by just pumping water back to the reservoir. Is as good as rain is falling in the reservoir through this pipeline. So this has been done in India. I think 2-3 places they have tried out. It's working satisfactorily. Government is hoping that they'll be able to do this in a big manner in India, and thereby storage by pumped hydropower can be used. Renewable energy, which is coming from the sun, drives this pump. Water goes up, water is released, and becomes electrical energy from hydro plant, hydroelectric plant. It is not from solar. Solar is used only to run the pump, but finally it is by hydroelectricity which you get. They say the efficiency is around 70%, and by doing this, we'll be able to reduce the impact of variability of solar significantly. So pumped hydro is one solution which we have to do in a very big manner. For every dam, everywhere there is a hydro electricity plant, we have to look at this, whether we can do it, and that pump can be run with solar power. Next, our target is 100 gigawatts from nuclear by 2047. It's been announced in the parliament last year. We will do it, or we'll work towards it. And I have got some submissions to make on that. 100 gigawatts from nuclear power. Today it is at 8. We have to go from 8 to 100 in the next 22 years. So government said we got some plants which are being built now. They will all get completed by 2035. So by 2035, we'll have 25 gigawatts. We are today 8, will become 25 in another 7-8 years. But we have reached 100 by 2047. So how do we do it? All our plants are running on uranium at this point of time. And we don't have enough uranium to feed all the plants. We have to import. And you can import uranium only if it's given by nuclear supply group. And nuclear supply group will give you uranium only if that plant is subjected to inspection by them. There are some plants in India which are not under inspection by nuclear supply group. But I'm sorry, inspection is by International Atomic Energy Group. So that agency, International Atomic Agency, they inspect your plant, whether you're using it for nuclear weapon or not, whether you're accounting for all the fuel, etc. Then only you will get your fuel exports cleared or imports cleared. But there are some plants which are not on inspection. There you can buy, we go to open market and buy uranium, Kazakhstan, Canada, Australia, all these are prepared to sell uranium to us. We got a little bit of uranium with us also, but that's not sufficient. So we can run. I'm assuming between 2035 and 2047, we will build some more nuclear power plants which will create 25 gigawatts more. Earlier it was 25, now 25, so it becomes 50. Our target is 100. Now, thorium. We have been struggling to make thorium run nuclear power plants for the last 10, 12 years. It has not succeeded. Results are not good. We're not cleared it for operation so far. But I'm assuming it will get cleared in 2027. Let's make a assumption. 2027, thorium will become, a project will become successful. And then we have time to build some thorium plant. Thorium is available in plenty in the beach sands of East Coast and West Coast and West Kerala, most importantly. So let's assume that 10 plants will be made of thorium. And Each plant is around 500 megawatts. That is 0.5. So another 5 gigawatts will come. So 50 has become 55. Now a new concept has come. You will make small modular nuclear reactors. It's called SMR. And their design is going on in India. Let's assume design will happen in another 3-4 years' time. The interesting point is this nuclear reactor will be fitted in the industry. Let us say there's a refinery which draws power from the grid. Tell him, don't draw power from the grid now. Install this small modular reactor inside your factory, and that will give you power, all your power. You will have a small nuclear reactor inside your factory premises. Maybe safeguarded well, secure place, all the safeties have been considered, but that will give you the power. And that is captive to you. Like you have a captive generator, you'll have a captive nuclear plant. This is the concept which is happening in many countries. So India is also trying to go into that. It's a great advantage. Your transmission distribution loss will reduce because you don't have to transmit from Kudamkalam or somewhere else to your factory. You can have a nuclear power plant in the factory premises, campus. Let's assume 20 such reactors we are able to install in India. And these reactors are small reactors. They can only do up to 300 megawatts. That is what the design is going on. So another 6, 55 has become 61. So all this put together, okay, I think I mistook somewhere. 25 plus 5 plus 56 is 56. We have a shortfall of 44. This is not 46, it's 44. 44 gigawatts. Where do we go? How do we do it? There is no uranium available for expansion. There's no thorium successful for another 2-3 more years. Small reactors are yet to be designed. So our nuclear power is not going to touch the target which we want. And that shortfall has to be met by pumped hydro. So you look at all hydro stations and pump water and see how much you produce. And if that is also not giving enough what is expected, then you have to go back to, because you can't depend on battery storage and solar and this because of variability issue. Of course, government has tried to do a green corridor by which power is available only from morning 6 to evening 6 and factories will run only. It is okay for certain type of production process, but certain factories cannot be worked. They have to work 24 hours. So there are some issues. So as I see it, there's going to be a problem, even though government is prepared. They have passed the Shanti bill by which private industries we can build and operate power plants, nuclear power plants now. All those legal issues have been addressed. But on the ground, there are some technical issues which may let us down on the power generation side. So can the private industry do it? Doubtful. But assuming it will happen, our power generation, which was in 25, which I told you earlier, produced so many gigatons of carbon emission. It went up in 2035. I told you 2035 will go up, and it's come down in 2050. Assumed to come down in 2050. So if all those nuclear and pump storage, etc., go as per plan, then we can control carbon emission. If they don't go, then coal will have to step in. And when coal steps in, this graph will go up because of emission. Now, so I come to my conclusions of this. India's transition may have achieved 50% capacity, but their intensity of emission of carbon emission has not been still realized because that study is still going on, but is expected to happen, but that's not much of a success. Fossil fuel is today 72%, and poor solar and other things are only 15% due to variability. It's a reality. The variability can be only countered by battery and pump storage. Battery means you have to make a lot of lithium batteries, huge batteries as big as this building. You have to have battery complexes in various places and store the battery electrical energy. And next day you can release it while it is charged by the solar panels and pump the water, which I already discussed. So reducing coal can only by storage and nuclear. Government's 2047 target seems to be very ambitious for nuclear. Pump storage, I'm not very sure how many hydroelectricity plants presently working can be converted for pump storage. It should be possible because the modification is not that difficult, but it is something which no clarity has come on this still. How many of the plants will be converted to pump storage? But if they assume it, then only half the solution is come. Nuclear is definitely 50% not going to come, as per me. And that is something which we'll have to face. And we have to substitute that part of nuclear with coal, as per me. So what will happen? Import will reduce of coal because we have contained pump storage to substitute coal. We'll use Indian coal, which unfortunately emits more carbon. Can't help it. If we don't want to import coal, we have to use Indian coal, which is available in plenty, but more carbon emission. And natural gas is very expensive, and we can't afford it. Whatever natural gas we produce in India is enough for meeting the other requirements, other industrial requirements for running auto rickshaws as CNG, compressed natural gas, or some small power plants. But major power plants which we have set up on gas, we cannot run because we don't have enough gas. If you buy gas from abroad, it's very, very expensive. You have seen it's almost 9 rupees a unit for getting power out of gas-based plant. So we have a situation that coal may have to continue as king even in 2047. So till nuclear and storage targets are met, king coal will continue and carbon emission may not get checked. If you have watched the budget day for yesterday, there was one statement by finance minister saying we are allocating a large amount of funds for carbon capture and suppression systems and storage. What is this? This is means in the exhaust which is coming out of coal power plant, we will have technology to remove the carbon out. Carbon capture world over has not been very successful till now. They're looking at various technologies, how chemically you can absorb this carbon. But India is hoping that they will be able to get a technology either imported or developed in India, and carbon capture will reduce the carbon emission. I thought it is a backup plan that if nuclear doesn't succeed, pump storage doesn't succeed, and coal comes back to the lead role, you will have the carbon capture coming into the factory, power plants to capture the carbon so that it is not released in an uncontrolled manner to atmosphere. I think only in another 4 or 5 years, only the picture will become clear. But I just want to share with you that on carbon emission side and air pollution side, we have got some worrying years ahead. Ladies and gentlemen, thank you very much. Jai Hind.